All right, today we're just going to briefly look at a little bit more solving inequalities, and then you'll work through just individually some other problems. All right, so this is a little bit of a different question, but similar to the inequalities from before. This time we want to create an inequality that has the following solution. So it's basically the reverse of the kind of question we were looking at. So what we need to remember is that for inequalities, the polynomial changes signs only at the x-intercepts. And it can't change anywhere else. So I'll write it down, use the fact that sign will change at the x-intercepts. And so then that means these numbers that we have here, -5, -2, 3, 8, these will be x-intercepts. Okay, so let's start with that. So we have x-intercepts of x equal to -5, -2, 3, and 8. Okay, so what I'm going to do is I'm basically going to kind of reverse the process that we had from before. So let's make a number line. We can even do like a little bit of a graph. We're going to start at -infinity. We're going to go to -5, go to -2, 3, let's extend it a little bit more, and then 8 with infinity at the end there. Okay, and what we want is we want the solution to fall within those areas. We just basically need to choose less than or equal to, or greater, or I should say greater than or equal to, or less than or equal to. It doesn't matter which one we choose. So what that really means is in the end, we can get multiple different answers. So I'm just going to choose, let's do greater than or equal to. So our inequality will be greater than or equal to. Okay, so what that means is the answer that we have up there, those intervals, are where our polynomial, our graph, is greater than or equal to 0. So that means if I'm looking at the number line, I'm going to identify those regions as greater than or equal to 0. So from -infinity to -5, that's going to be positive. -5 to -2, well, it's not part of our solution, so it must be the opposite, negative. -2 to 3, also not in our solution. You'll see that -2 is included, and you'll see that I chose equal to in both of those inequalities because we have the closed brackets. We are reaching the x-axis, so that's why. And we have 3 to infinity is part of our solution, so it's going to be positive. And then 8 to infinity is not in our solution, so it's negative. So we have kind of our regions of positive and negative. And what I'm going to do is I'm just going to do a rough little graph of what our function might look like. So our function might go to -5. And at -5, the sign is changing, so it's just negative. And then it goes to -2. And, well, it stays negative. So it hits -2 and goes back. Then it goes to 3 and becomes positive. And then it goes to 8 and goes back down to negative. Okay, so there's like a very rough, just kind of sketch of the graph, but why I did that is it will help us to figure out what the order of these roots are, because that's really the only other information we need. Because as long as we can write these roots down, so if I write the roots down, x plus 5, x plus 2, x minus 3, these are the roots as their factors, x minus 8, that's essentially our polynomial. And we want our thing to be greater than or equal to 0. But yeah, the last thing is we just need to know the order. So if we look at -2 where it's not changing signs, well, you can see it kind of has that quadratic, that parabolic shape of order 2. All the other ones go straight through, so all the other ones will, in that case, be just exponent 1. Okay, the other thing we just need to be careful of is we just need to make sure, is the end behavior going to be okay? In this case, we have a positive lead coefficient, and the exponent would be, or the degree would be 5, which would actually end up going positive towards infinity. If we want something to go towards negative, when we go to towards negative infinity, as x goes to infinity, we need a negative in front. So yeah, we need the negative lead coefficient to be able to end with minus in the intervals. Yeah, because whatever our lead coefficient is, that's what our polynomial will go to as we go to infinity. So if it's a positive in front, you're going to be positive value as you go towards infinity. If you're a negative in front, you're going to be a negative value as you go towards negative or to infinity. Okay, and so therefore, let's just write this out as kind of a final answer. Therefore, negative x plus 5, x plus 2 squared, x minus 3, x minus 8, greater than or equal to 0, will have the above solution. We'll have the solution. And what is it? Let's just remind ourselves. So negative infinity to negative 5 with a closed bracket, union. So the 2 is there. It's just a single point, so that's why it's just the single number. It's not really an interval, and it should write negative 2, not just 2. And then from, 3 to 8. And that matches what we wanted. All right, and so that's a look at that particular problem. So now you should have on your lesson sheet some thinking problems. So work through those, work in them in groups, try them out. Don't just look at the answers that are going to be posted, but do actually try these questions out yourself. And then when you get stuck, keep trying a little bit longer. Then after only a certain amount of time, then you can look things up. All right, that's a look at just some final things. And make sure to also just go through some review and preparation for a test.